Welcome to my talk. I will talk about IoT security and hack the damn vulnerable IoT device. First of all, who am I? I'm Arnaud Courty. I'm a security pen tester at Soprasteria in Toulouse. I'm a IoT hacker, security and geek, and I'm a IoT security evangelist. What we'll talk about? First, why we are interesting about IoT hacking. We take focus about to hack the IoT world, and we will explore the top 10 OWASP IoT with a real-life example. Also, I would like to explain you how could we learn step-by-step IoT hacking with a DVIT project. And I will explain DVID objective, tear down the project timeline, related product, and I try to make a live demo without video. And we make a conclusion about DVID roadmap. Why we are interested in IoT hacking? First, IoT is a growing market. In next 4 years, there is four times more connected device around the world, and whole markets become an IoT leader, like industry, transport, or health. But also there is a new paradigm. In the past, where an attacker would like to attack a server, he must follow and access only open ports, like SMB, FTP, or HTTP. So blue team could make sensors on ports and detect what the attacker do. In future, the attacker could get many information offline. In this example, you have a smartwatch who communicates with a smartphone, like Android application, and after to the cloud. And before to make requests to the cloud, the attacker could reverse the smartwatch, reverse the Android application, and and learn how the system works before make some requests. So, IoT security assessment. There is two methods to assess security. Firstly, the pen test. Pen test, you are engaged on time, not on results. You must follow an analysis process, and you will receive money even if you find CVSS. If you find vulnerabilities with a score CVSS -2. But in bug bounty, you are engaged on result, not on time. You can spend 6 months to find a vulnerability. You must find an exploitable vulnerability to get money, and you need to be the first to discover this vulnerability. If you are the second, it's a duplicate, and you can just go to next. So, go to hack the IoT world. I would like to take the top 10 OWASP IoT and I will illustrate it by real-life example. On hardware, you can find weak guessable or hard-coded password, insecure default settings, or a lack of physical hardening. About the middleware, like Android application or iOS, you can find insecure ecosystem interface, a lack of secure update mechanism, or use of insecure or outdated components. On the exchange, you can find some insecure data transfer or storage. And on the cloud, you can find insecure network services. But in more general, you can find privacy and management vulnerabilities, like insufficiency of privacy protection or insecure data. No, c'est ça. Sorry. So let's go to the first one. Weak guessable or hard-coded password. You have received an IP camera for Christmas, but you don't have the root password, and the root password is not provided in the manual. So you can download the firmware on the support website, the manufacturer website, like support.company.com, You can use binwalk to extract it automatically. You can find its Jefferson partition inside, and you can use the correct tool Jefferson to extract it. You will find a Linux file system, and you can use John the Ripper to crack it. The password is simple, I know, but is not provided in the manual. About insecure network services, how does your phone access to the IP stream? So you have the camera, you plug it on a network, and you just could scan it with Nmap, and you find it's a RTSP protocol. So you can use a script with Nmap, like RTSP-URL-brut, to find URL to access the stream. When you find it, you can use VLC to be connected to it, and you can take a tour on Shodan to find a useful IP stream, like in radio or Chinese office. About this, the 3-point insecure ecosystem interface, could you access to premium services? Here, your device is a temperature sensor, and a premium access, a premium service, offer access to all other device sensors. So I won't like to pay. So the service is insecure. Use insecure API that allow you to enroll all devices. So the activation key is a declaration, and the serial number is predictable. With two things, I can, for my attacker account, I can add all other accounts, and I can go to data mining to reverse engineer access to all other device sensors. About lack of secure update mechanism, how to unlock advanced features. Here, from an Android application, you can get the firmware directly, because on the there is no information in manual to get an update. You must follow the process in the Arnaud application. So you can download it. You can extract with extract-firmware.sh. It's similar to binwalk, but you can rebuild it for the firmware after. So you can explore it, and you can modify the firmware to unlock advanced features. When done, you can rebuild the firmware, re-upload and flash the device, and access. Here, there is no signature encryption on the firmware, and no firmware encryption to protect the device from this vulnerability. About use of insecure or outdated components, how to copy physical RFID key. Here you have an alarm system. We need that MyFair Classic badge, like VGIC, for example. And outdated MyFair Classic badge are sensible to two vulnerabilities, nested and dark side attacks. And you can done in a couple of minutes a simple copy. So here you can find the copy with mfoc and a writing process in a Chinese page, for example. About insufficient privacy protection, the use case is how to track physical movement of a user while staying seated on your chair. Here, some applications offer you to share your location with friends or family. But this application uses MQTT protocol to share your location to the server and offer a subscription process to all your family and friends. So you can find the MQTT server on Shodan because the topic of MQTT is the name of the application. So you can get every 2 minutes the location of all family and friends, and you can map all of them with a simple script and see all movement around the day and see that they are where they live and where they work. How about insecure data transfer and storage? Here, how to rob a bicycle. Some padlock have Bluetooth features to be unlocked with a mobile phone. And for example, in use case, you can give the right to unlock the padlock to a friend. A padlock receives orders from an application through Bluetooth Low Energy. Here, you can just listen to traffic and extract. There is 3 orders. The first one is to wake up the padlock. The second one is to put the code. Here is 000. And the next is to unlock order the padlock. So a simple relay of captured command allow you to unlock the padlock. There is no nonce or protection about replay attacks. So I didn't do this attack at the metro station because unlocking is simple, but I can't lock padlock. So after a script, all padlock are unlocked, but I can't lock them physically. So I stay here. About lack of device management, how to spoof a physical access badge. Here, a physical access badge was moved to a smartphone application, and publishing under the company publish non-secure application allow to attacker to reverse engineer the protocol. So the application is not obfuscated, so you can just read the code, understand it, and write a wildcard application. So that I made them, and the application asked me which door would you like to open. Just enter the number. And the application, the wildcard application, emulates the badge and unlocks the door. About insecure default settings, here you can have fun with default credentials. You can take a look on Mirai source code and take the dictionary of password, and you can just connect to your IP camera, for example. But here you have a weak password, but you can't change it because by default many IP cameras works on read-only mode, so you must flash the firmware to patch the vulnerability, and you have a 50-50 chance to break the device if you bring another firmware. So it's vulnerable and you can do nothing. About the last point, how to extract protected firmware. So you can download from the manufacturer website only encrypted firmware. So you can first you can find a UART port to access to limited shell or load to update process to inspect the bus's memory. Here there is pictures of UART port. And also you can access to boot sequences with, for example, TFTP, and if the TFTP protocol is enabled, you can read the memory and extract data to a server. So what did we learn? We learned how to challenge the OWASP Top 10 IoT. We learned that to improve yourself, you can read write-ups and try yourself on a real-world IoT device during, for example, bug bounty programs. But you need also to improve yourself with open sourced vulnerable system, and I developed for that a DVID project. So what is the DVID project? It's a damn vulnerable IoT device. It's the first open source IoT project designed to be vulnerable. It gives interesting people a vulnerable board to improve their skills in IoT hacking. It's cheap, less than 40 euro. It's simple, only well-known components like Atmega 328P, and could be bought easily or just do it yourself with the Jabber files on GitHub. You can find more details on the official website, dvid.eu, and there is no official shop today because I don't have time to upload it. So just contact me on Twitter. So about Teardrone. The DVID project, there is an hardware part with the board and the Atmega 328P. It's same like a Arduino Uno, but it's a custom board. There is an OLED screen, a regulator for the Wi-Fi board, and a status LED used for flashing process, for example. About communication port, you have hard flash with USB ASP and UART port for access to serial console, for example, and a limited shell. About communication, you have Bluetooth with a 80-09 plus adapter feature and Wi-Fi with an ASP 8266. The full package is 40 euro. To all is included. You just need to have a computer. So the project is simple. In order to learn how to exploit a vulnerability, you just have 3 steps. The first one is to flash the corresponding firmware on the DVID. The first 2 is to understand objectives and start to attack. And the step 3 is to find vulnerabilities and exploit them. Simple. Here you have an example for the hard-coded password training with the progression process. About timeline, the project started on February of this year with a prototype, so it will be very beautiful now. There is no whiteboard yet. On March, production process is engaged with soldering, and since May, there is a English e-learning course with Hacking9 and TripleSec conference, for example. And I present the project at other events like STHack, French e-learning course, GreHack here, and SigSeg V2 on November, and Net Secure Days in Rouen in December. Today, there is 250 boards sent worldwide. For example, to make one board, you must spend 15 minutes. So you can imagine the huge time to make the little letters. About functionalities, there is about hardware. You can try to a board analysis. Like review all layers and what the developer write on it. About firmware, it's extraction, buffer overflow, default password or hard-coded passwords. About Bluetooth is replay attacks, scan for vulnerable devices, device firmware updates, for example. And about Wi-Fi, it's vulnerable web interfaces or man-in-the-middle attacks, for example. So the project is cool, but there is also related products. First, the DVID package. So I have some of them in my bag, but it's available for everyone. It could be sent worldwide. It contains all all hardware and needed attack tools. You just have to, you just need to have a computer. And optional course, it's currently in development. But also, there is a briefcase. It's dedicated to physical course, for example, for teacher. It contains 20 DVI-ID full package board, a flash station, and a scoreboard for the final exam. But also, I developed an escape game. The escape game is a live game for 10 players maximum. 10 players because there is many interference with Bluetooth. So if we are 100 in a room, it's not, you can do nothing. It's focused on protocol exploration like hardware, Bluetooth, Android, and cloud protocol. There is a live scoreboard and player follow-up. And the first release is at the ZigZag event on the 30th of November. The scenario is simple. You see CISO is asking you to investigate about security failure on the production line, and your subcontractors seems to be hacked, and a backdoor might to be installed. So this objective, and you have just 1 hour to find the vulnerability. So it's not enough. There is a board game. I have time with Superstar also. The board game is currently development. It's a real case study dedicated to companies. So, for example, it's a thermal supervision of a cold chain, physical access detection system, multi-technical level. I would like to give access to this game to beginners and nerds. But it's limited to companies for now, because companies have money to pay my research and development. So for now, it's dedicated to companies. So, demo time. So you have here, it's real because the board is in the box. So real. Here, it's the Bluetooth. It's the Bluetooth training. You just have the objective. Come on to say hello on the 000 FFE1. So, if you do some Bluetooth attack, you can see that maybe it's a Bluetooth characteristic. So you can first scan Bluetooth devices. So HCI tool, HeliScan. It will give you the opportunity to see the DVI-ID board. So I have the MAC address of the DVI-ID, and I can use the BLE tool with B, with -E to explore characteristic of the device. Please don't do the same as me, because you will fail the demo. So the BLE will connect to the board and scan all things about it. And you can see that the FFE1 is a real characteristic, and the characteristic has the right rights. So you can try to send hello to this characteristic. So you can use the same tool, BLE, -B the MAC address, -D for data, hello, -N for the characteristic. Characteristic is here, 0025. So BLE will connect to the board, and you will see in What? In X format is better. Enter a past, hello, and the challenge is completed. So the demo is successful. So I would like to take a focus on warm-up. So the escape game is not enough about time. The board game also. I plan to do more trainings and on more protocol, like 433 MHz radio frequency, Zigbee, Modbus for industrial devices, and LoRa or Sigfox for cloud communication. I also would like to develop a newbies starting kit because I have some beginners that bought my project. I would like to develop an all-in-one interface with a course and guidelines to do trainings, and a video course with a live interaction. That's also, I would like to develop the DVI version 2 with a Bluetooth 5.1 Sigfox or CAN bus. So thank you for your attention.
Thanks a lot for the talk and the demo. I think we have the time for a couple of questions.
Thanks for the talk. Two questions. The first one, is your device vulnerable to a Blueborn attack on the Bluetooth stack? And the second one, it's a lead for the assembly of the board. Do you check GLC PCB SMT assembly tool to make a board automatically?
The board is a traversal soldering only because I would like to allow to all people to solder the board. So I would like to have a simple board, but I understand that the soldering process is take more times. Because I can go to China to build the board automatically. But today all is done in Toulouse. I have friends that would like to solder, so so they solder. All 500 more boards today. And the first question?
Yeah, the first question was about Blueborn and the Bluetooth stack, if it's vulnerable. Yes or no?
Maybe.
You'll have to get the board and try it out. Okay, let's thank or maybe we have time for one more question. Last one?
Yes.
Any takers? Actually, one question from me. How long did you actually spend on this project, if you had an assessment of number of hours? And did you do this as part of your work or on your private time?
It's totally in private time. It's absolutely not correlated to superstar companies. About time, more than 300 hours, night and weekends. Wow. So yes, but today some painful function like soldering all boards. It's done by friends, so I can focus myself on the development of the whole roadmap and escape game or a board game.
Okay, great. Let's thank our speaker again.
Thank you.